Hi, this is Mrs. Ricard, and today we're going to talk about factoring special products. When we first learned about multiplying together binomials, we learned that you would distribute the terms in one parenthesis through the second parenthesis. And when we talked about factoring, we sort of worked that backwards to see how we could break down something that was in the multiplied out form. So these were some of the results that we got, or these were some of the actually things we looked at and multiplied together. I'm going to start with this one because it's the most normal one to multiply out. When you have a binomial times a binomial, you take this term times the first term over here, that gives you a squared, and then it times the second one, and that gives you minus ab. And that was this times both of these, so now you go to the next term and you multiply that and you get plus ab, and you multiply this and you get minus b squared. But because these were the same two terms, and one had a plus and one had a minus, these two middle terms end up canceling out. So all you're left with is a squared minus b squared. This kind of a form is called a difference of two squares because both terms are perfect squares and they are subtracted. That's why we call it a difference. So if you see something that looks like two perfect squares that are being subtracted, that means you can factor it into the two square roots in two separate parentheses with a plus in one and a minus in the other one. So instead of having to go the long way to try to work things out, you can recognize this form and use a shortcut to factor it. When we had things that looked like these, where you just had a binomial squared, remember that means you're really multiplying this binomial times itself. So it's more like this, except where both sides were the same. But if these two signs were the same, these two terms wouldn't cancel out. They'd add together to make it double. So when you multiply this out, we learned a shortcut for this. You square the first term, you multiply the two terms together and double it. So AB times 2 is 2AB, because remember, doubling just means multiply by 2, and square the second term to get plus b squared. This form is called a perfect square trinomial. It's got three terms, that's why it's a trinomial, and it's a perfect square because it's the result of squaring a binomial. To recognize it, you see that both ends are positive and perfect squares, and the middle is twice the product of the square roots of the ends. If you see that a trinomial has perfect squares that are positive on both ends, and then if you take their square roots and multiply them together and double them, and that gives you the middle, then you know it's a perfect square trinomial, so it factors into the square roots squared. The sign here is the same as the sign here. The only difference when it's minus in between is, again, you square the first term. When you multiply these together, you get minus ab, so when you double it, you get minus 2ab, and then plus b squared. Because remember, negative b times negative b would be positive b squared. So this is also a perfect square trinomial. So the pattern you're looking for to be able to use these shortcuts. For a difference of two squares, you see two terms that are both perfect squares with subtraction in the middle. And if you see that, that means you can factor it into the square roots of the two terms in two sets of parentheses with a plus in one and a minus in the other. If you see three terms where both ends are positive perfect squares and the middle term is double the square roots, then it's a perfect square trinomial, and if the middle is positive, it's a plus b squared. If the middle is negative, it's a minus b squared, where the a and the b are just the square roots of the ends. So here are several examples. Now I'm going to remind you, when you're factoring, the first thing you should do is put it in standard form, which means from highest to lowest powers, if there's one variable. If there's two variables, like there is in this problem, you pick one of them and go from highest to lowest with it. And you want the other one to go from lowest to highest if possible. Then you look for a common factor. Is there a number that will divide into both or all three terms? Looking at these problems just overall in general, here 64 and 16 will have a common factor, so I'll need to take that out first. Here 10, 14, and 4 all have a common factor because they're all even, so I'll have to take that out first. In this one, not only do I have a common factor of 2, but remember, when we're factoring, we run into problems if we have our first term being negative. Just it makes it a little more confusing because it doesn't fit the pattern, so I like to always factor out the negative if the leading coefficient is negative. And this one here is going to have a common factor that we have to factor out. So I'm going to go through those problems and factor out the common factor. Remember, when you do that, you want to take out the greatest common factor. That's the biggest number and or variable that will divide into all of the terms. So here, the biggest number that will go into both 64 and 16 is 16. So 16 goes into 64 4 times, and the c squared is still there, and 16 goes into 16 once. In this problem, 2 divides into all of these. 10 divided by 2 leaves me with 5c squared. Negative 14 divided by 2 gives me negative 7c, and 4 divided by 2 gives me plus 2. Now, I'm not done with these. I'm just going to go back after I've factored out the first common factor and then see what the next step is going to be. In this one, 2 goes into all of these, and because the leading term's negative, I want to factor out negative 2. So if I divide the first term by negative 2, the negative 2's cancel and just leave the x squared. Negative 16x divided by negative 2 gives me positive 8x. And negative 32 divided by negative 2 gives me plus 16. On this problem, this one isn't in standard form, but because there's only 2 terms, I'm not going to really run into too many problems if I leave it this way. However, there is a common factor of 12, so when I factor that out, 12 goes into 12 once, and 12 goes into 48 4 times. Now I want to look at these problems and think about the special forms that we were talking about above. I'll start with the difference of 2 squares because it's the easiest to recognize. It's called the difference of 2 squares because there's only 2 terms in the polynomial. Now, in these ones where you factored out a number, you're just going to carry that number along. It's not part of what you're worrying about factoring. You're not going to throw it away, you're just going to bring it along with you. So this problem has 2 terms. They're both perfect squares and there's subtraction in between. So it's a difference of 2 squares. This has 2 terms. They're both perfect squares and there's subtraction in between. So it's a difference of 2 squares. This one has 3 terms, so it's not. 3 terms, it's not. 3 terms, it's not a difference of 2 squares. Not a difference of 2 squares. This is not a difference of 2 squares, but this has 2 terms. They're both perfect squares and they're subtracted. This has 2 terms. They're both perfect squares and they're subtracted. So all of those ones that I just pointed out are difference of 2 squares. So when you're going to factor a difference of 2 squares, you make 2 sets of parentheses. Now in this one I've got to carry the 16 along beside them. And in this one I've got to carry the 12 along beside it. Now in a difference of 2 squares, the numbers that you fill the parentheses with are the square roots of the 2 terms. The square root of the first term goes at the beginning of both sets of parentheses. The square root of the second term goes at the end of both sets of parentheses. And then because that second term has to be subtracted, that means these two numbers have to have opposite signs. So I put a plus in front of one of them and a minus in front of the other. So y plus 3 times y minus 3 will give you y squared minus 9. You can check it by multiplying it out if you wish. Now here, two terms, both perfect squares, subtracted. So the square root of 4c squared is 2c, and I put that at the beginning of both sets of parentheses. The square root of 1 is 1, so I put that at the ends of both sets of parentheses. And because this is negative, these have to have different signs, so I put a plus in one and a minus in the other. Down here, square root of x squared is x. Square root of 81y squared is 9y. Plus in one, minus in the other. Over here, square root of 1 is 1. Square root of 4m squared is 2m. Plus in one, minus in the other. It doesn't matter whether you put the plus here or minus here, because they're exactly the same until you put those in. And in multiplication, order doesn't matter. So notice, I recognized the pattern before I started factoring. When I noticed that the pattern was difference of two squares, then I knew it had to have two sets of parentheses with the square roots of the two terms and a plus in one and a minus in the other. Now let's look at the other ones, the ones that had three terms. Now, just because they have three terms doesn't mean it's a perfect square trinomial. We have to first look at the ends to make sure they're both perfect squares. And 9c squared and d squared are both perfect squares. But we also need to check the middle. When the ends are perfect squares, it might be a binomial squared. If it is a binomial squared, then the first number would be the square root of the first term, which would be 3c. And the second number would be the square root of this term, which would be d. But if it is a perfect square, then when I multiply these two things together and then double it, which just means multiply that by 2, I should get what's in the middle here. 3c times d is 3cd times 2 is 6cd. So it is a perfect square. Now, the sign that's here has to be the same as the sign that's between them. When you square this negative d, you're going to get positive d squared. But when you do your middle terms, when you multiply these together, it comes out negative. So when you double them, you're going to have a negative answer there. Looking at this one, remember we already looked for common factors. It didn't have one. Both ends are positive perfect squares, so it might be a perfect square trinomial. If it is, I need one set of parentheses squared. And the numbers inside would be the square root of a squared, which is a, and the square root of 9, which is 3. But before I decide for sure that it is a perfect square trinomial, I multiply these together, that's 3a, and double it, and that gives me 6a. So it is. So the sign in front of the middle term goes in between them. On this one, notice that these ends are not positive perfect squares. So this is not a perfect square trinomial. That means I need to use the method we learned last week to solve this one, to factor this one rather. We're not solving because there's no equal sign. So I'm going to have to carry that 2 along. But now I'm going to make my little line. I'm going to put factors of 5 on the left. And I'm going to put factors of 2 on the right. And then on one of the two sides I need to put them in both orders. So I'm going to put 1 and 2 over there. And I need the products that add up to 7. Well, 10 plus 1 does not add up to 7. But 5 plus 2 adds up to 7. So these are the two pairs that I need. I'm going to put my two sets of parentheses. The 5 and the 1 go on the left sides of the parentheses, just like they were on the left side of this line, with the square root of this variable. So I'm going to have 5c and 1c. Remember, you don't have to write the 1 in front of the variable. The 5c got multiplied by the 1, but if you put the 1 here, the 5c wouldn't be multiplied by it. It would be added or subtracted to it. So to make sure it's multiplied by the 1, you have to put it in the other parentheses at the end. And the 1c was multiplied by the 2, so again, it has to go in the other set of parentheses. And then the last thing you had to do was decide about the signs. If the constant term is positive, both parentheses get the same sign, and the sign you use is the sign of the middle. So this would be the factorization of 10c squared minus 14c plus 4. Now that one was not a perfect square trinomial, but that means we just go back to our previous lesson to figure out how to factor it. On this one, both ends are positive perfect squares, so it could be a perfect square trinomial. So I'm going to try it. The square root of 4n squared is 2n. The square root of 25 is 5. If I multiply these together, that's 10n times 2 is 20n. So it is a perfect square trinomial, and the sign I put in there is plus. On this one, I have to carry along that negative 2. Both ends are positive perfect squares, so it could be a perfect square trinomial. Square root of x squared is x. Square root of 16 is 4. If I multiply these together and double it, 4x times 2 is 8x. So it is, and I use this sign in between. Now, these are solving, because notice they have an equal sign in them. And we've talked about solving quadratic equations. That's these things with powers of 2 on the variable. Remember that we had to get 0 on one side, and then we factored them. Because if we get things that are multiplied together that equal 0, that means one of the things has to be 0. If you don't have 0 on one side, you're not going to be able to factor it to solve it. So this problem already has 0 on one side. Now looking at this, you see this fraction and you go, I don't know how to do it with fractions. But pay attention. 25 and 4 are both perfect squares. So the square root of this would be the square root of 25 over the square root of 4. So this is a perfect square, and so is this. So it looks like it's a perfect square trinomial. There was no common factor to take out here. So the square root of x squared is x, and the square root of 25 over 4 is 5 over 2. Now to check it, I multiply these together. That's 5 halves times x, and then I double it, so that's times 2. The 2's cancel, and that gives me 5x, which is the middle term. So I put the minus sign that was in front of the middle term there. Now, if I was just asked to factor, I'd be finished, but this time it said solve. So once you've got a product that equals 0, you take each factor. Now, this problem only had one factor. It was squared. So you only have to solve it once. So we get x minus 5 halves equals 0. We'd add 5 halves to both sides. And that gives us x equals 5 halves. And that's the solution for this equation. In other words, if you replaced x in this equation with 5 halves, this would be true. For this problem, notice we don't have 0 on one side yet. Since the variable has a power on it, we need to make sure we have 0 on one side. So I'm going to add 9c squared to both sides. So I get 0 equals, and when I have a positive term and a negative term that I'm adding together, I like to write the positive one first, so then I can just write it as a subtraction problem. Now, we're only looking at one side here. There are only two terms on this side. They are both perfect squares, and there is subtraction between them. So that means these are a difference of two squares. So I put two sets of parentheses. Square root of 9c squared is 3c. That goes at the beginning. The square root of 16 is 4. That goes at the end. We have to have different signs so that the 16 ends up negative, so I put a plus in one and a minus in the other. This time I have two different terms. So I have to set each one equal to 0, and then solve them. So here I would subtract 4, and that gives me 3c equals negative 4, and then I would divide by 3 to get c equals negative 4/3. In this one, I would add 4, and that gives me 3c equals 4, and then I would divide by 3, and that gives me c equals positive 4/3. So this equation has two solutions, both positive 4/3 and negative 4/3 substituted for c would make that equation true. The last thing I want to do is look at an application for this problem. There is something that we study in science called projectile motion, and it tells you the relationship between how high an object is a certain amount of time after it was either dropped or thrown. And there's an equation about projectile motion that says that the height of the object is equal to a constant, which is it's a result of whatever gravity the planet you have is on, and we'll talk about that in just a second, times the time squared, plus v sub 0 means the initial velocity, which means how fast was the thing moving when it started, times t, plus s sub 0 is the initial position. So g is what we call the gravitational constant. And on Earth, when you're measuring in feet, it is negative 16 feet per second squared. V sub 0 is the initial velocity. Initial just means at the start. And S sub 0 is the initial position. And in this case, we're talking about height. So if I look at this problem, I have negative 16 for g. I was dropping the rock. So if you're dropping something, it is not moving until you drop it. So its initial velocity was 0. And it started 4 feet above the surface of the water. So its initial position was 4. And we want to know, when does it hit the water? Well, when it hits the water, its height would be 0. So the equation that we need to solve here is 0 equals negative 16t squared plus 4. Well, notice that if I switch the order of these terms, it's 4 minus 16t squared. It has two terms. The two terms are perfect squares, and they're subtracted. So that means it's a difference of two squares. But before I go there, notice there is a common factor here. So I'm going to factor out the 4. 4 divided by 4 is 1. 16 divided by 4 is 4, and the t squared is still there. And now 4 can never equal 0, so that doesn't give you any solutions. But we're going to factor that difference of two squares into 1 plus 2t times 1 minus 2t. So if 1 plus 2t equals 0, we subtract 1. and we get 2t equals -1. So you divide by 2, and you get t equals -1/2. If you set 1 minus 2t equal to 0, I'm going to add 2t to both sides, and that gives me 1 equals 2t, and then I divide by 2, and I get 1/2 equals t. Well, it said, after how many seconds did the rock hit the water? After you dropped it. Well, you can't go backwards in time, so your time can't be negative. So the answer is, it hits the water after 1/2 second.